So what if the entire future of artificial intelligence isn't on Earth at all? We're about to dive into a wild research project that wants to build AI's ultimate brain, where it can be powered directly by the sun. And I mean directly, in outer space.
Look, AI's appetite for energy and data is just growing exponentially. Our planet, well, it has limits. So the central question really becomes, if we want to unlock AI's absolute fullest potential, where do you go when Earth just isn't big enough anymore? Well, according to a brand new research initiative from Google, the answer is up. And I mean way up. They're calling it Project Suncatcher, and they're framing it as a true moonshot. You know, one of those audacious, long-term bets on the future of computation itself. And let's be clear, this isn't just about launching another satellite. The mission here is to fundamentally rethink where massive-scale machine learning even happens. The goal is to build the entire infrastructure for AI from the ground up in space. You know, this kind of big thinking isn't exactly new for them. It's part of a legacy of these moonshots, these long-term, super ambitious bets on the future. I mean, think about the decades of research that went into self-driving cars, or the mind-bending physics of quantum computing. Suncatcher is really just the next chapter in that story. Okay, so the vision is huge, absolutely massive. But it also begs a really obvious question, right? Why go to all this trouble? Why on earth would you move our most advanced, delicate computing hardware into literally the most hostile environment known to humanity? Well, the ultimate ambition is to build an AI so powerful it can help us solve humanity's biggest challenges. We're talking everything from climate change to curing diseases. But an AI that powerful, it needs an almost unimaginable amount of energy to run, way more than our grids on Earth can easily provide.
And that brings us to the core advantage of being in space: energy. Pure, raw energy. Once you're above our atmosphere, a computer network has direct, 24/7 access to the most powerful fusion reactor in our solar system, the sun. This unlocks a virtually limitless and clean source of power for computation.
So how would this whole thing actually work? What are the core components of a giant solar-powered brain just floating around in orbit? The concept is actually pretty elegant when you break it down. Step 1, you build a huge interconnected network of satellites, a whole constellation of them. Step 2, each one of those satellites gets equipped with powerful specialized AI hardware, and then finally, the entire network is powered by massive solar arrays. It's basically a data center just totally reimagined for the vacuum of space.
Now, that specialized hardware is absolutely key. We're talking about TPUs, or Tensor Processing Units. These are not your standard computer chips. Nope, they are custom-built accelerators designed for one thing and one thing only: running massive machine learning models as efficiently as possible. You could say these TPUs are the brains of the entire operation.
A solar-powered data center in space? I mean, it's an incredible vision, right? But how do you actually get from a research paper to a functioning reality? What are the practical first steps to make this happen?
Well, the work is already underway. An initial research paper lays out the foundational challenges, things like designing the perfect satellite network, figuring out how to control and talk to it from Earth, and, this is a big one, testing whether their delicate TPU chips can even survive the constant bombardment of cosmic radiation you find up in space.
So you can really see the journey laid out here. Today, it's a research paper, tackling these fundamental, tough challenges. But the finish line? It's nothing less than a completely new paradigm for computation, operating on a massive scale, hundreds of miles above our heads. And hey, this isn't just theory. The project has a very real, concrete first step on its roadmap. By early 2027, they're planning to launch 2 prototype satellites in partnership with the satellite company Planet. This is going to be the first crucial real-world test of their hardware in the incredibly harsh environment of order.
So, let's zoom out. Beyond all the technical details, what does this all mean for the big picture? If a project like Suncatcher actually succeeds, what are the real implications for the future of computing?
Ultimately, this is about way more than just one project. This is really about laying the groundwork for a whole new era of computation, one where our progress is no longer bottlenecked by the energy we can produce down here on Earth.
Which leaves us with one last, pretty fascinating question to think about. If a project like this succeeds, if we truly untether computation from its earthly limits, what great challenges will we solve next? What becomes possible when the only real limit is our own imagination?